Okay, let's finish up section 12.4, our matrix algebra section. This is 12.4b. And so we have two objectives here, objectives 4 and 5. First one, objective 4, find the inverse of a matrix. Okay, so what is the inverse of a matrix? It is the matrix that when you multiply it by the original matrix gives you an identity matrix. And it has to work in both directions. So inverse times the original also needs to equal an inverse. And remember that not inverse, I stands for identity. Remember the identity is 1's on the diagonal. This would be the I3 matrix. Okay, so that'd be a 3 by 3. They have to be square as well, 3 by 3. They always need to be an n by n matrix. If we're n by n, we're going to call it a square matrix. All right, so let's take a look at one. Show that the inverse of A and A minus 1, show that they are inverses of each other. So let's do this multiplication. So going first, we're going to have negative 3 times negative 1, which would be 3, plus negative 1 times 2, which would be negative 2. And row 2, column 1 would be 4 times negative 1. Negative 4 plus 2 times 2 is 4. And let's go back to row 1 and column 2. Negative 3 times negative half is 3 over 2. And negative 1 times 3 over 2 is minus 3 over 2. And now bottom row and right column, 4 times negative half is negative 2. And 2 times 3 halves is positive 3. If we clean this up, we've got a 1, a 0, a 0, and a 1. Look at that. We've got the identity matrix. Now we need to go the other way as well. This was A times the inverse of A. We need to do the inverse times A as well. So let's go ahead and do that here. So we've got first row is negative 1 times first column 3. And we're going to say negative half times 4 is going to be minus 2. And then let's go with first row, second column. And so that's going to be negative 1 times negative 1, which is a 1. And negative half times 2 is minus 1. And then we're going to go second row. 2 times first column is negative 6. And then 3 halves times 4 is going to be plus 6. And then last row, last column. So 2 times negative 1 is negative 2. And then 3 halves times 2 is plus 3. And here we go. We've got a 1, a 0, a 0, and a 1 again. So that we have shown that they are inverses of each other. All right, so that's long way. That's doing it by hand. Let's go ahead and introduce the calculator version of this. So we've got the steps for doing this by hand. We're actually going to be able to skip this to find the inverse. I'm going to allow you to find inverses using the calculator. All right, and so here's how it's done. First things first. Non-singular means that it has an inverse. Non-singular, there is an inverse. Singular, that'd be the reverse. No inverse. So if it's non-singular, it means we have an inverse, and so we can go ahead and find it. Let's do that. Let's grab our graphing calculator and move it over so we can see our original matrix. I'm going to plug this in. So again, second matrix, we're going to edit. Let's go ahead and edit matrix A to be a 3 by 3. And we'll punch in the numbers 1, negative 1, 2. Second row, 0, negative 1, and 3. And third row, 2, 2, and 1. And we'll go ahead and get back to our mode here, and let's go ahead and find the inverse. It's just this straightforward. You go matrix, you bring up A, so it's sitting there, and the inverse is negative 1. So A to the negative 1 is, and there we go. We're going to have our inverse of this. Let's go ahead and get our answer in fractional form. So where are we? Second math. If you haven't done this before, oh, it's not second, it's just math. To turn decimals into fractions, hit the math key. It's the first one there. Change to fractions. Answer into fractions. And there we go. 7/9, negative 5/9, 1/9, all the way through. Okay, that would be the inverse of our original, okay, of this matrix. And so we always do want to check this to make sure it does work out. So Let me take a second to write these numbers down, and then I'll punch them into our other matrix. 7/9, -5/9, 1/9, and we've got -2/3, 1/3, and 1/3, and then we have -2/9, 4/9, and 1/9. So let's go ahead and plug this into matrix B. This will be a 3x3 as well. And so just going back in here, we had 7/9, we had -5/9, and we had 1/9. Row 2 at -2/3, 1/3, and 1/3. And then last row, -2/9, 4/9, and 1/9. And so this was matrix B. Let's go ahead and do A times B. Cross your fingers. Aha! We've got an identity matrix, an I3, ones on the diagonal. All right, so we've proved the inverse of matrix A. All right, so knowing what we know now, try problem 31. Okay. Show that this matrix here has no inverse. Let's do this. We can use our calculator as well. Let's punch this in, and we can do this. We can change up matrix A to a 2x2. -2, 1, 4, -2. And so we'll grab matrix A, and we'll do the inverse. And air, singular matrix. That's matrix is being cut off there. All right, so if you get the singular error, that means it has no inverse. If you get a different error, something else is going on. Maybe you didn't put the right numbers in somehow, and it said, hey, we can't do things. But if the error is singular, that means, hey, there is no inverse. All right, so we've just proved that there is no inverse using the calculator. And again, we're not going to learn how to do it algebraically in this chapter. We're going to be able to use the calculators for these inverses. All right, so knowing that, try problem 59. Okay, last objective here. We're going to learn how to solve a system of linear equations using an inverse matrix. This is going to be fabulous, especially for 3-variable systems of equations like this. No more having to do it by hand. Here's what we're going to do. We're going to take all the coefficients and throw them into one matrix. So we've got 1 minus y plus 2z. So don't need the plus, just 2. We've got 0x minus 1y plus 3z. We've got 2x plus 2y plus 1z, okay, times, in another matrix, we're going to put the variable names. X, so it's not an x, so that's timesing, x, y, and z equals, and then we're going to put the solutions over here, 1, -2, and -1. All right, we're going to call this matrix A. We're going to call this matrix B, and we're going to call this matrix C. All right, now if we have A times B equals C, and B is the matrix that holds all the solutions for the x, the y, and the z's, we want to get B all by itself. How do we get rid of the A over here in this equation? We're going to multiply both sides by the inverse of A. Okay? And so now we're going to cancel this out. We're going to have B equals, and we're going to put it in front of it, A to the -1 times C. And the reason it goes in front is because of the rows times columns. Remember, this is a 3x3, and this is a 3x1. So this 3x3, 3x1, remember we have to have the inside dimensions matching up. If we did C times the inverse of A, we would have a 3x1 times a 3x3. Oop, couldn't do it. All right, so make sure you do the inverse times the C. So let's go ahead and grab our graphing calculator and plug these things in here. So we're going to need to plug in 2 matrices here. So matrix A will be a 3x3 with our coefficients 1, -1, and 2, 0, -1, and 3, and 2, 2, and 1. And let's go ahead and edit matrix. Let's go ahead and edit matrix C here, just so we keep our letters matched up here. And so matrix C will be a 3 by 1. And matrix C was 1, -2, and -1. All right, let's go back and multiply these things. So it's going to be the inverse of A. So A and then inverse times matrix C. And what do we get? X equals that, Y equals that, Z equals that. Let's have some nice fractions here. So X equals 16/9, Y equals -5/3, and B equals -11/9. And so we could go back in and check this. Let's do that. Let me write these answers down. 16/9, -5/3, and -11/9. Let's go back and check them real quick. Back to the matrix we go. Let's edit matrix B. This will also be a 3 by 1. And so this will be 16/9. This is going to be -5/3. And this will be -11/9. And so if we go back home and multiply A times B, 1, -2, and -1, what we started with. So we have just solved for X, Y, and Z. X was 16/9, Y was -5/3, and Z was -11/9. All right, so you can solve systems of equations doing this, and the beauty of this is you can solve 4 by 4, or 5 by 5, or 6 by 6, as long as it's an n by n, because you can only have an inverse if you're n by n, then you can solve using this method. All right, problem 43 is yours to solve. After that, you're all done. Any questions? Make sure we're going over them in class. Good luck.